Okay, so the majority of this lesson is actually going to be review of stuff we either did in pre-calculus or in limits. Um, and then we will end this lesson with something new for 30-1. So odd even functions we actually looked at in pre-calculus. And odd even functions are whether or not your function is symmetric about the y-axis, whether your function is symmetric about the origin, or neither. How we determine if a function is odd or even is we are going to plug into the function a negative x. So into whatever function we're given, we're going to plug in a negative x. If the output is my original function, f of x, what that means is the function given is even. And even means that it has symmetry about the y-axis. So let's look at this example here, 4x squared minus 5. Now, hopefully you're able to visualize this function from your quadratics unit in 20-1. So this function is a quadratic, and it has a y-intercept at -5. And we know that quadratics are symmetric. And this one would be symmetric about the y-axis. So this is what the graph would look like. But how we're going to prove that it is symmetric about the y-axis is into our function we're going to input negative x. So 4 negative x squared minus 5. F of negative x is equal to, we would get 4x squared minus 5. The output, when I input negative x, my output is my original function, right? My original function was 4x squared minus 5, so f of x. So what I could say is I could say f of negative x is equal to f of x. Therefore, my function given is even. It's going to have even symmetry about the y-axis. Now, when we were doing pre-calculus, I did sort of show you a little bit of a shortcut you could do. This would be if you need to show your work. But looking at this, I know that the degree on this x squared, or on this term here, is a degree 2. 2 is an even number. This would be x to the power of 0. 0 is an even number. Overall, this function is going to be even. This function here, doing that same shortcut, this is to degree 3 and to, or sorry, power of 3, power of 1, x to the power of 3, power of 1. Both are odd numbers. This is going to be an odd function, but we will show that by inputting f of negative x. So if your function is odd, we're going to input a negative x. And if you get negative in front of your original function, so negative f of x, then you will have an odd function. Okay, sorry, where was I? If we input negative x into our function and we get our function with a negative in front of it, so basically negative factored out, then that is going to indicate that our function is going to be odd. Okay, so if this occurs, then f is odd. Odd functions are symmetric about the origin. So this, if you look into quadrant 1, this piece is going to first be reflected in the y-axis, and then it's going to be reflected down into the x-axis. Okay, and that would be symmetric about the origin. So let's prove this one. F of negative x is equal to 4 negative x cubed plus 7 negative x. F of negative x is equal to negative 4x cubed minus 7x. I'm going to factor out a negative 1. F of negative x is equal to negative 4x cubed plus 7x. This 4x cubed plus 7x was my original function with a negative in front of it. So I could state that f of negative x is equal to negative f of x. Therefore, my function is odd. Odd is symmetric about the origin. Classify the following functions. I know, based on this degree 8, which is an even number, that this is going to be an even function. But to show my work, f of negative x is equal to negative x to the power of 8. Negative 1 times negative 1 times negative 1, 8 times will give me a positive 1. F of negative x is equal to 8x. this was my original function, and I could say that f of negative x is equal to f of x. Therefore, f, my function, is even. It'll be symmetric about the y-axis. This one here, f of negative x is equal to negative x cubed plus 1 over negative x. F of negative x is equal to negative x cubed. I'm going to bring this negative to write it as this. I'm going to factor out a negative 1. And I'm going to get x cubed plus 1 over x. And f of negative x is equal to negative f of x. Therefore, the function is odd, and it'll be symmetrical with the origin. One thing I want to note when we actually start sketching our graphs, the majority of functions will be neither even nor odd. So we won't get this scenario or this scenario, and then we would just say it's neither even nor odd. The other important thing about why does it matter if a function's even or odd? It's simply because I could give you, let's just say this piece in quadrant 1, and then I could say to you, based on symmetry, the function is even, then you would know that if it's even, that graph would look like this on that side. Homework for even odd functions is page 206, number 128F.